Advent of Code is back with 2015. So, I mean, we have a lot of years to get through before 2023 December, when the actual 2023 Advent of Code will start. So, will I have time to get through them all? I don't think so, but we can try a few. So, 2015. Oh, I'm not showing the browser. Hang on. This is going to be a recurring problem, me forgetting to switch between the browser and the IDE, so I just have to get better at remembering. All right, so for those that don't know, Advent of Code is a kind of a free challenge website where you can practice programming in a language of your choice. It starts in December the 1st. And each day up until Christmas Day, they release a new problem each day. And it's very popular, a lot of engagement, lots of people do it. And then you can kind of discuss in the forums how you did each problem, how you solved each problem, or ask for solutions and stuff. It's a really great community activity, and I highly recommend it. And every year it gets more popular. And the creator of this, Eric Wastel, he stopped by my stream on one of those days, so shout outs to Eric for creating this site. So I'm gonna go back and do 2015 because I never did this. So let's do this. Before I start, let me get my important things. Is there a bit of graphical glitching here, or is that actually part of the look of the site? Oh, it's actually part of the look. Okay, interesting. All right, let me make sure. Yeah, my mouse is showing on screen. Okay, what else do I need? Copy is what I need. So yeah, it starts off easy, and then it gets hard. In the final few days, or even somewhere in the middle, it can get hard as well. Like, some problems are just phenomenally difficult, but they're doable. But it'll take a few hours, so people think December, the days leading up to Christmas, is a nice holiday, but no, for us programmers doing Advent of Code, December is like the hardest we work all year. I mean, seriously, I put more hours into coding during Advent of Code than I did in my actual software engineering job. Don't tell them I said that. All right, got my coffee. So yeah, as I said, we start off easy. In fact, I won't limit myself to one per stream. To begin with, I'll probably do a few per stream because I can probably churn them out quickly. I say that, maybe I won't. Maybe I'll get stuck on these early ones for hours, in which case, see how it goes. All right, I think it's about time to start. Make sure I'm showing the... Oh, no, we want to show the browser. Okay. Ready? 2015. Begin. Also, I should actually zoom in a bit. That goes for the IDE too. All right, let's see. Day 1, not quite Lisp. So I guess it's going to be something to do with... Oh, I can see parentheses, the classic example. I mean, it's a good example, especially for functional languages. All right. Santa was hoping for a white Christmas. Oh yeah, there's going to be a whole story as well. Santa was hoping for a white Christmas, but his weather machine's snow function is powered by stars, and he's fresh out. To save Christmas, he needs you to collect 50 stars by December 25th. Okay, we've got time. We've got time. Collect stars by helping Santa solve puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Here's an easy puzzle to warm you up. Santa is trying to deliver presents in a large apartment building, but he can't find the right floor. The directions he got are a little confusing. He starts on the ground floor, floor 0, of course, and then follows the instructions 1 character at a time. An opening parenthesis means he should go up 1 floor, and a closing parenthesis means he should go down 1 floor. Oh, okay. So it's actually simpler than what I was thinking. These are literally just symbols. They don't actually need to be closed. Okay. The apartment building is very tall, the basement is very deep, and he will never find the top or bottom floors. Okay, so it's a number line. It's an infinite number line. For example, blah, blah, blah. Doesn't even matter the order. Okay. To what floor do the instructions take Santa? Alright, puzzle input. I mean, I can already see some really quick ways of solving this, but I'll try to balance speed with readability and understandability, but... Alright, so... Switch to... IDE. Definitely need to zoom in here. How do I... Let me start typing. Alright. How do I zoom in? No. You'd have thought zoom would be right here on the front window. It's pretty important. Window. View. Should be under view. Appearance. Increase font size in all editors. Alt Shift plus dot or Alt Shift dot, Alt Shift comma. Okay. Alt Shift dot. Does that look better? Alright. Alright, let's begin. So we've got our input here. And we've got this. Alright, so how do we type code in Python? I forget. With open put as f s equals f dot read line dot strip. Is it as simple as just doing this? Result. Okay, so we've got the string now. Result equals s dot count. So what was it? It was open bracket to go up 1 minus s dot count close bracket to go down 1. Is that it? Whoops, that's not how you do that. $280? Alright, well, this will be embarrassing if I get this one wrong. I should have tested on the example. But I didn't, and I got it right. Okay. Part 2. Given the same instructions, find the position of the first character that causes him to enter the basement. Okay, so we have to go character by character now. The first character in the instructions has position 1. Hello, Slippy Goat. It is indeed Advent of Code 2015. I should add an Advent of Code tag to my stream as well. Let me just do that. Advent of Code. All right. So this time we just have to. Will you do multiple questions back to back or one a day? I think I'll just do multiple questions because, at least early on, because some of these look easy enough. But once it gets to the hours, as it usually does, then I'll probably do one per stream, not one per day. I'm probably not gonna do this stream every day, but one per stream. Maybe we'll see how it goes. Right now, I'm gonna see how many I can do this stream. When it comes to December, 2023, I'll actually try to do it properly, like one per day. I managed last year. No, not quite. Some of them I had to kind of finish off the next day or so, but I was close. Thanks for the good luck. Have you done any of these? Did you do 2022, the last one? Rather off and on. Same for me, yeah. I mean, I've done 2022 and 2020 to completion, so only 2 years. But from now on, I'm gonna commit. All right, let's switch back to. Wait, so the key numbers we need are. Oh, it's one indexed. Okay, fine. And we want to get to -1, and we start at floor 0 because because that's the British system, isn't it? You start at 0, and in America you start at 1. And then in every other country, it's a mixed bag, and I always get confused. Like in Hong Kong, it's normally under the British system. Anyway, and then when you're in China, of course, you have to skip out every 4 and every 14 because 4 is bad luck. And then when you're in Malaysia, not only do you have to skip out every 4, but you also skip out 13 as well because that's bad luck too. So you end up with 11, 12, 12A, 12B. Okay, I'm going way off topic here. Why is it not showing up? Whoops, hang on. Ah, there we go. So you've done 2015, 2020, 2021, 2022. Ah, okay. Cool. Oh, yeah, 2020, you've done 38 stars. Are you planning to finish those off? I also have a leaderboard link. I can't remember where it is. I'll probably have to dig it up. Some questions get boring. Yeah, there were 1 or 2 that I found pretty frustrating. And let me show this on stream in case anyone sees this video and decides to join my leaderboard. How do I... Ah, okay, that's it there. Well, anyway, if anyone's watching this video, because I will upload it to YouTube eventually and would like to join my leaderboard, then you just have to copy that code there. I'll probably paste it in the description or something. Seems I'm still a member of Reali's. I don't think she's active anymore. Okay, back to the coding. Oh, I'm in the chat of someone YouTube famous. We'll see. It does give me the most attention. These coding streams give me way more attention than I do get from gaming, which is what I mainly do. So people like coding streams. I wouldn't really have thought it. Like, I don't really watch coding streams. Not really found them that interesting, to be honest. But apparently people do, so I guess whenever I'm watching a coding stream, I feel like I'd rather just be coding. I guess that's... A lot of people watch coding streams, but they don't actually code themselves. They're kind of maybe the target audience. All right, what we're doing here. So now we want... So that's part 1. Part 2. But I did have Eric stop by my stream once, so that's my claim to fame. Eric, the guy who made Advent of Code and who continuously maintains it. Maybe he'll drop by again. Eric Wastel is his name. He's the guy behind Advent of Code. He does all the problems. I asked him if he does if he like competes on other sites like Coding Game and HackerRank and all those things. He says he doesn't because he doesn't want to be accused of stealing problems, because that can happen even unintentionally. You know, you see a problem, you forget you saw it, and then you actually end up accidentally copying it. So he doesn't partake in all these competitions and stuff, which just makes it all the more impressive, because that means he's really genuinely making these up himself. He's not even really using inspiration from other problems he's seen. So that just makes it impressive. Like, if I were to make problems, I would definitely be taking inspiration or semi-copying other problems I've seen. I mean, I'm sure he uses paradigms, like, you know, common algorithmic paradigms, but I mean actual problems. He mostly seems to... Yeah, exactly. Okay, pause equals 1. Floor equals 0. While floor not equal to -1. Let's pause plus equal 1. Floor plus equal 1 if the character that we're looking at I've got these indexes confused. All right, just stick with this. Equals that, else -1. So when we break out of this, we're looking at -1 floor, and that means pause is the answer, right? Print pause. 1797? You never know with these. It's so easy to make some slip up, even with these easy ones. All right. Done. Day 1. I'll update the stream to say day 2. Alright, day 2 already. I was told there would be no math, as they say in America. Math. We say maths. Who told you there would be no maths? Of course there's going to be maths. It's advent of code. The elves are running low on wrapping paper, and so they need to submit an order for more. They have a list of the dimensions, length, width, and height of each present, and only want to order exactly as much as they need. Fortunately, every present is a box. Right rectangular prism. I don't need to click that, I know what that is. Which makes calculating the required wrapping paper for each gift a little easier. Find the surface area of the box. Don't need the formula. I know boxes. The elves also need a little extra paper for each present. The area of the smallest side. So they need the smallest side again. Okay. Alright. So we're gonna have to list the size and take the smallest. Okay, got it. Got it. Ugh, square feet. Alright, easy enough. Let's get my input. Oh, very white. Is there a way to make this inverted colors? It's hurting my eyes. Okay, let's quickly save it. Alright, let's do this. So, let's make a new file, we'll call it 2. I'll also try to make this, clean, so it prints the result for part 1 and it prints the result for part 2. I think last time I didn't quite manage that. I sometimes edited my part 1 to part 2, and then I ended up with something which is only part 2, which kind of annoyed me, but I think a couple of times I went and fixed it. I thought hang on, I didn't correctly save this. Oh, I saved it into 2022. There we go. All right. So sides. So, okay, we can just do this. Sides equals, so we take the string, strip the new line character off, dot split on the X symbol. So that'll get us the 3 numeric strings. Int Z for Z in. So sides is now a list of sides. Smallest equals min sides. Well, are we printing the total area across? Yeah, we are. Okay. All right, so we're accumulating this. So area plus equal. So it'll be it's oh, no, hang on. I've interpreted this incorrectly. These are not the... No, this is length, width, and height. So this is not... Okay, got it. All right. This is not the sides. These are the... Well, it's the edge lengths, but not the side areas. Okay, so to get the side areas, we need to do... Okay, let's say edges equals that. All right, so I would say sides equal... just write this out explicitly. Don't need to find some clever way of zipping it or something. Okay. So there's 3 sides. Smallest is the min of the sides, and then the area is going to be 2 times the sum of sides plus slack for the smallest. Is that it? 3276. Oh, too low. Okay, I did rush through this a bit. So all right, let's go back to the so we get the let's just run through this logic again. We get the 3 numbers. I should probably just print what I'm doing here, but just read it, the logic first. Okay, so we get the 3 numbers. Okay. Then the sides are first multiplied by the second, first multiplied by the third, second multiplied by the third. Okay. The smallest is going to be the smallest side. Smallest rectangular face. And then area we add. So each side gets counted twice because there's 1 on each side. And then we add extra slack for the smallest. Seems right. Okay, let's try the test example then. That's what it's there for. So the test example was 2, 3, 4, and 1, 1, 10. Two, 3, 4, 1, 1, 10. 2, 3, 4, 1, 1, 10. 58. Not well. It's 58 is correct for the first one, but we should be adding 43. Hang on, area plus equal. Oh, damn it! I didn't do a for loop. For line in f.read line. I didn't go to each line. It was just one line. So it's 58 plus 43. Yeah, that's right. Okay, that's more like it. Correct. The elves are also running low on ribbon. Ribbon is all the same width, so they only have to worry about the length they need to order, which they would, again, like to be exact. Okay. The ribbon required to wrap a present is the shortest distance around its sides or the smallest perimeter of any one face. But those two things just rewordings of the same thing. Shortest distance around its... Yeah, it is. Okay. Each present also requires a bow made out of ribbon as well. The feet of ribbon required for the perfect bow is equal to the cubic feet of volume of the present. Don't ask how they tie the bow, though. They'll never tell. Alright, I can start coding this in. So the ribbon, the first bit of ribbon, shortest perimeter. Hello, Amaro. It's a coding stream, which I did in last December, and I'm doing another one. It's called Advent of Code. So this website, at Christmas, on the 1st of December, they release a problem, and then each day until Christmas, they release a new problem. They're like puzzles, which you can solve. But I'm doing kind of like the backdated ones. I'm doing the ones from, this one is from 2015 because I didn't know about this site back then. So I'm kind of doing the old archived puzzles. But come this Christmas, I'll do the live 2023 Advent of Code. I did the last one for 2022. It was a lot of fun. It's very popular. There's a lot of engagement, so you can a lot of people stream it and then put their videos up on YouTube, and then there's lots of discussions about how people solved it. And so yeah, anyone who does any coding, I think would enjoy it. I think you do coding, don't you, Amaro? Wait, Amaro, you are the one who's making that game. Have I got that right? The As the Dreams-esque game? Yeah, you are. Okay. So I guess you do a bit of coding at least, but this branch of coding is kind of mathematical coding, which I mean, it is actually it does tie in well with any sort of game dev, so I don't know, you might like it. But it does get quite difficult. Like, it starts off easy and then it gets difficult. Like this here, we're just calculating volumes of cuboids, which is totally a thing that one would do in game dev. Later on, it gets really complex with like graph algorithms and stuff. But how is that game coming, by the way? Are you planning to make a demo? Like, I used to do lots of AI streams as well, where I coded AI for like bots, but I haven't done them as often because the website that I normally use is not running those competitions as often. But there is one coming up. I don't think it's going to be as long as they normally are. It's only going to be like... Yeah, I want to get the demo out this year. Nice. Okay, while this is still in my head, let me finish this bit off. So we want ribbon, the smallest perimeter of any one face. Okay. So perimeters, face. Oh, I need to switch windows. Yeah, I would say, well, I've never really made a game, but I've tried to work with some game dev teams with games that never really kind of ended up finished, as is normally the case for 90% of games. But AI was always my speciality. Like I have taught workshops at universities on writing AI for games. I did one this January, actually. They flew me to Saudi Arabia, especially for that workshop. It was only 4 days long. And I had my students like basically write bots for pathfinding. It was quite fun. It was like, what was the game we were coding for? It was like Bomberman. I had them write bots to play Bomberman. And we basically learned breadth first search, how to use it to find a path, how to use finite state machines to decide when to start placing your bomb, when to flee. I want to... Whenever there's another one of those AI coding competitions, I'll probably do a stream series, because they last like 2 weeks, so I normally spend a lot of time and several days worth just like streaming myself writing AI. But there's one coming up. I don't think it's the type of competition I like, because it's just a very short 2-hour one, but normally it's like 2 weeks long rather than 2 hours long. 2 hours is a bit rushed. Face perimeters equals 2 times... I used to write bots for the AIbattles.com. Oh, it's shut down, is it? Yeah, that's a shame. A lot of these competitions are shutting down. I guess this kind of hobby, this competitive coding hobby is maybe in decline. Like last week, I was told that my all-time favorite coding competition, Google Code Jam, Google has decided to stop the competition. That was quite legendary. I've been doing that since 2012. That was my favorite coding competition, and as Google likes to do, they're shutting it down as they do with all their products. Okay, 2 times edges 0 plus edges 1. So that's 1 perimeter. You take 2 sides and 2 sides, okay. And then just do the same again for... So change this to a 2, change that to a 1, and that to a 2. So that's the face perimeters. Smallest perimeter equals min face perimeters. So what did we want? We wanted the smallest perimeter. And we also want a bow, and the bow is equal to the volume. So volume equals... Isn't there a thing in Python called product, which I almost never ever use? No, there isn't, is there? I could have sworn that was a thing. Maybe I'm thinking of a different language. It's rubbish though, because the numbers will be too big. They'll just blow up combinatorially. So yeah, we just want volume equals okay, we've got all the things we need. Now what? We need ribbon. I can't spell ribbon. Ribbon equals 0. Oh, I'm just imagining that. I don't know why, but I'm imagining that scene from Love Actually with Mr. Bean, Rowan Atkinson gift wrapping the present, and he's like being really meticulous about how he wraps it, and the guy is just waiting for him to wrap up his present, and because he's in a rush. Very funny scene. All right, so now the ribbon. We want ribbon plus equal. That plus volume? Did I get the thing I wanted? I'll have to double check this. We want smallest face, perimeter of a face, and we only count it once. Yeah, that's right. And the volume. Okay. But this looks like a maths problem. How does it force you to use code? Well, you have to use code to solve it, because if you did it by hand. So the puzzle input is this. You have to sum up the amount of wrapping paper and ribbon for all of these and give the final total. So maybe there are 1 or 2 problems you can actually do by hand because the input's small enough. And I have seen people do that, but in general, you're just kind of wasting time trying to do it by hand. It's quicker to use code. And some of them it's hopeless. You need to check millions of paths, so it really is code focused. But they unlike some websites where you gotta submit the code and they run the code in their virtual machine. In this case, it's pretty flexible. You can just run the code on your own IDE. You only have to give them the answer. And Also, anyone who's watching my stream or watching my video or whatever, they can't actually just copy that answer, because if they go on this site, they get given different parameters. So you can't really cheat by copying other people's answers. You can copy people's code, that you can do that. But yeah. Okay, we're done. Problem number 3. So we're building a tree here. Alright, I can update the stream. We're on day 3 already. Build a hex tree. You know, nice bit of hex tree lore here. I got my username originates from the Discworld. That's a series of Terry Pratchett books, which are popular in the UK. There's a character, well, it's actually a computer called Hex in the Discworld books. He's basically a computer, but he's powered by magic. And he's physically powered by ants. Like, you have an ant colony going through like holes in tubes, and the magic kind of blocks certain tubes to make them go certain ways. It's an ant powered machine. But yeah, that's where I got Hex from. I identified with that computer in the Discord. Oh, you know it, good, because lots of people I describe that to don't know the Discworld. It's quite a British thing, but it does have a following outside of Britain. But it has a much stronger following within Britain. Alright. Perfectly spherical houses in a vacuum. Santa is delivering presents to an infinite 2-dimensional grid of houses. He begins by delivering a present to the house at his starting location, and then an elf at the North Pole calls him via radio and tells him where to move next. Moves are always exactly one house to the north, south, east, or west. After each move, he delivers another present to the house at his new location. However, the elf back at the North Pole has had a little too much eggnog. I can't remember the last time I've drunk eggnog. I guess because of the salmonella scare, it became less popular. But you can get like pasteurized eggs, so. But there were those graphic adventures that introduced me to it. Then I read the books. Are you talking about the video games? The Discworld video game? Because I really want to play that. I will at some point. It's like a point-and-click game, isn't it? Where you play as Rincewind the wizard. Yeah, that looks fun. It looks. I've heard it's kind of frustrating at times because it's one of those point-and-click adventures where you can actually get permanently stuck if you don't do things in the right order, and you have to either restart the game again or go back to an earlier save because you can very easily soft lock yourself. That's how those games were in those days. Yeah, I plan to play that at some point. And there's some movies. There's like 4 or 5 movies. They're not amazing, but they're kind of like low budget movies, but they're nice. There's one based on Hogfather, one based on Color of Magic, the first book. Because I remember they were shown on BBC, like Christmas specials, a few years back in the UK. So his direction's a little off, and Santa ends up visiting some houses more than once. How many houses receive at least one present? Okay, this is a hash map problem. Pretty much, we just want to use a hash map to record visited houses. Hash set. We can use a set because we don't need a lookup table. All right, let's have a look. Whoa, okay. Wait, do the lines matter here, or it's just from each line we just take all the... Okay, yeah. Lines don't matter. It's just get all the inputs. All right. Have you ever looked at the Discworld MUD? So it's an MMORPG, but without the graphics. So it's an actual... It's still fairly popular. It's actually one of the more popular MUDs, like text-based multiplayer RPGs. But it's based in the Discworld universe, and it's supposed to be quite good. I might like to try it at some point. It just doesn't have graphics, it's all text and ASCII based. So you have to use your imagination a lot of the time. But it's supposed to be very well developed, like they've built a whole Discworld world. You can build up your character, you can travel to different parts of the Discworld and have different, you can, you know, different classes. You could be a wizard or a troll or whatever. Yeah, it's basically an MMORPG, but there's no graphics. That's the summary of it. Oh, this is one line. Okay. All right, so starting start equals, let's say 0, 0. Visited, we want a hash set, so set start. Is that how you initialize a set with something in it? I think so. For in the string, so for each character, we want to check whether it's one of those arrows and move. Let's not say start, let's say pause, because it's changing. So x, y, let's unpack the x and y coordinates. If car is that one, x plus equal 1, elif car equals that one, x minus equal 1, elif car equals, is it small v? Yeah. We'll have y increasing downwards. That's normally what you do in these problems. Else, oh, we'll still do LF just so it's clear what the final case will look like. New pause equals the new xy. Visited. Oh, no. Pause. Pause is, we want to rewrite pause. Visited dot add. So we put that in the hello Bad for Beans. Thank you for the Hexasexa Meshman. I'm back to the advent of code grind. At this rate, I'm not going to get all the years done before 2023, December 2023. I've got, well, I'll show you the calendar when I switch back. So, then finally, I want to print the length of visited. So that's how many have been visited. So it handles all duplicates. 2592. All right. We're gonna get it right first try. Correct. Yeah, so I started doing I discovered Advent of Code in 2020, and I did it that December. And then 2021, I don't know what happened, I forgot about it. And then 2022, last December, I did it again. But now I'm going back and doing all these archived years because, you know, I want to do them. I doubt I'll be able to do them all by this December. I mean, it takes, you know, it takes about a month to do them. If you're doing like one problem a day. Some of the problems take hours each. All right. All right, part 2. Oh, I need some food. I've got some pistachio nuts. Alright, part 2. The next year, to speed up the process, Santa creates a robot version of himself. AI. It's replacing everyone's jobs, even Santa. Robo Santa to deliver presents with him. Santa and Robo Santa start at the same location, delivering 2 presents to the same starting house, then take turns moving based on instructions from the elf, who is egg-noggedly reading from the same script as the previous year. This year, how many houses receive at least 1 present? Also, they alternate. So we just need a flip-flop, a boolean, to keep track of whether we're now looking at Santa or whether we're now looking at Robo. Okay. Easy enough. Oops, just knocked my camera out of position and it's not back on. Hang on. Alright, so if I want to do this, I need... Okay, let's just duplicate this. Alright, so we've got pause. Let's make this a list of 2. So the first one is Santa and the next one is Robo. It doesn't matter who, it's just as long as we alternate. And we want an index which is going to keep flipping. So I equals 0. So for character in S, we always extract from the ith pos. And then we do I equals 1 minus I. So that flips I. So when it becomes 1, we'll then switch to changing the other one. Okay, that's all we need to do, right? And then again, print the length of visited. Two, 3, 6, 1. So it's fewer because I guess there's lots of overlap between their paths. So you would expect it to be fewer. Oh, too high. Oh, wait. Oh, that's not the problem. All right, let me read the example again. They start at the same location, then they take turns moving. Right. And it's at least one present, same as before. Okay. What did I do wrong? So we're resetting visited, so we're not using the old stuff. Putting 0, 0 in there. I equals 0, so we're using okay, then we change pos I to be the new xy. Plug that into visited. Flip I. All right, what's wrong here? Let's try the example then. So the example they have is well, okay, they got a pretty simple example. Okay, just do that for now. So just up and down should be 3. Correct. And now this one should still be 3. 4. Alright, this is wrong. Let's have a look at what's actually in there. Oh, why is 0 in there? What the? Okay, we're 1 off. How did 0 get in there? Pause 0. Do we have to put a comma here? Is this one of those weird things? You have to indicate that it's... I think... Oh, it's taking this tuple and it's turning that into a set instead of putting that tuple into the set. It's just a weird... It's a weird thing about set initialization. So actually what I have to do is... that. And I should also do it for this. But this was actually working, but there we go. All right. 2360. So I was one off because I had a extraneous 0 in there. That's correct. All right, we're getting there. We're on day 4. The ideal stocking stuffer. Hang on, let me sort this out. Alright, so Santa needs help mining some Advent coins. Very similar to Bitcoins. To use as gifts for all the economically forward-thinking little girls and boys. To do this, he needs to find MD5 hashes, which in hexadecimal start with at least 5 zeros. I mean, yeah, that is pretty similar to how the Bitcoin algorithm works. The difficulty is set by how many zeros you need at the beginning of the hash. And when the difficulty increases, they increase the number of zeros you need to have at the start of the hash. So when you're mining Bitcoins, you're trying to find a hash. You're trying to order your transactions in a way that it'll just happen to have a hash with lots of zeros at the front. And if you manage to find it, then boom, you are the discoverer of that Bitcoin and you get the Bitcoins. And you'll be very rich. Alright, the input to the MD5 hash is some secret key. your puzzle input given below, followed by a number in decimal. You must find the lowest positive number that produces such a hash. So if your secret key is A, B, C, D, E, F, then the answer is R. So you're choosing the number to append to the end of the string such that the hash starts with 5 zeros. Ooh, interesting. This is a good problem because it introduces you to the basic principle of Bitcoin mining. This is actually how mining works, except you have to do it a lot more efficiently. Okay. Oh, this is my input. It's just that string. All right then. What integer are we starting with? 1? Okay, yeah. Problem 4. So we start with that. The number you append, you can call it say S seed equals 1. While true. So I'm trying to use the correct terminology here. So let's call this the key, the seed, and let's say string S equals key plus seed, like that. Then we want to take the MD5 hash, which I've never tried to do in Python. How do you do that? Let me Google this. Python MD5 hash. In code, we need to use import hashlib. All right. If let's print this. I just want to see what it looks like. Strings must be encoded before hashing. What? Hang on. Ah. We need to we need to encode it into bytes. Okay, so we use oops, not there. Is it what is it? Hash lib dot encode? Hang on, I don't understand this. Ah. No, you're supposed to. No, it's not hashlib.encode. It's s.encode. That's a Python method. All right. Okay, so we've got a hash object. Dot. We need we need hex digest. That's a nice method to extract the raw string. Okay, got it. So what we want to say, the logic here is if hex digest dot starts. This is quite a technical problem, but it's good. This is a good thing to learn. Starts with 1, 2, 3, 4, 5 zeros. Break. Seed, and keep increasing the seed until we find print seed. All right, let's try that. There we go. Now all we need to do is create a computer which can do that, compute MD5s really fast, and then we'll be the richest guy in the world. All right, let's try this. Correct. Yeah, it's not really a problem you can go wrong on, because it's certifiable. When you've got the answer, you can verify that you've got a hash that starts with 5 zeros. All right, now find one that starts with 6 zeros. Interesting. All right, let's switch back. Is it going to time out or something? I can't see any way we'd be able to speed it up though, because you know this is kind of advanced stuff, speeding up hashes. Just put an extra 0 in then. See what happens. mean, if this times out, I know of no other way to do it. Okay, good. And I'm pretty sure there wouldn't be one, other than like running it on a supercomputer or something. Woohoo! All right, we are racing through these. Not really. I could do this much faster if I was not getting distracted continuously. Problem 5. All right, we're 1/5 of the way through almost. Doesn't he have intern elves for this? Santa needs help figuring out which strings in his text file are naughty or nice. A nice string is one with all of the following properties. It contains at least 3 vowels, like A, E, I. Okay, got it. It contains... Wait, 3 distinct vowels? I mean, would AAA... I guess it would, right? AAA would contain 3 vowels. It doesn't matter that they're not distinct. It contains at least 1 letter that appears twice in a row. XX. Okay. It does not contain the strings A, B, C, D, P, Q, or X, Y. Even if they are part of one of the other requirements. Okay. Straightforward description. All right, then. So we want to count the number of nice. All right, so we've got a string. Just like, let's just strip the characters off. All right, so we want to check 3 conditions. Does it contain, how many vowels does it contain? I'm still not clear on whether they're counting distinct or... Ah, yeah, they've got an example. AAA is nice because it has at least 3 vowels. Okay, then that's unambiguous then. All right, so let's say requirement 1 equals sum. So we're counting up the booleans. So sum of R in A, E, I, O, U for car in S is greater or equal to 3. So that will give us a Boolean true or false if the number of characters which are in A, E, I, O, U across that string totals 3 or more. All right, rec 2. We want to find, so we need we need a letter to appear twice in a row. Okay, fine. That in operator looks really cool. Yeah, I like you. This is a very Pythonic way to do it. Because if you did this in like C++ or something, it wouldn't quite be as compact. You would probably be doing a for loop and keeping a running count and all this stuff. But this is really functional. And you can do string handling is great in Python. It's the best language for string handling, especially, but also generators and list comprehensions, which is what this is. So rec2, we can say any si is equal to si plus 1 for I in range length s, but excluding the last one. So that's saying we let I range from 0 to the index 1 before the end, and we check the Boolean if this character is equal to the next character, and the any operator does an OR condition across all those Booleans, and it short circuits. So if it finds a true early on, it stops computing the rest, I think. Yeah, it should do. So that's requirement 2. And then the final one, what was it? It does not contain the strings A, B, C, D, P, Q, or X, Y. So rec3 equals not any say T in S for T in A, B, C, D, P, Q, X, Y. A, B, C, D, P, Q, X, Y. Is that right? So we're saying there are no T's amongst this list such that T is in S. Python's almost cheating for this one. Yeah, I mean, that was the case. So last December, there was some problems which were, took hours to do in any other language, and was completely simplified in Python, like brought down to one or two lines. That's just the beauty of Python. Trying to think what that was. So Python, you can evaluate, you can run code, you can type, you can make a string, which is like or X and Y or whatever, and then you can make that string, and you can do eval of that string, so it would actually run that as if it was code. So there were some places where that was incredibly useful because they gave some weird questions involving code. You can also do, if they give you strings which are like sums, so like 5 times 7 minus 4 or whatever. You could do eval k, and that will get whatever the answer is. 5 times 7 minus 4. So that's basically parsing arithmetic expressions without having to write a parser, which is also very useful. You can do that in JavaScript as well. So JavaScript users also had some benefit, but yeah, it's nice. So I think at this point I just want to say count plus equal rec1 and, so it's only, we count 1 if rec2 and rec3 are all simultaneously satisfied. $255. Very programmy number. Which makes me suspicious. Okay, that's right. Game Maker used to have that execute string, I think it was called, but they removed it for some reason. I mean, it comes with the downside that it's quite slow, because you're evaluating a string of code is pretty slow. So it might be a problem for game dev if you're doing that while running the game. Part 2. Realizing the error of his ways, Santa has switched to a better model of determining whether a string is naughty or nice. None of the old rules apply, as they are all clearly ridiculous. They weren't that ridiculous. Now, a nice string is one with all of the following properties. It contains a pair of any two letters that appears at least twice in the string without overlapping. Okay, fine. So there are two distinct substrings of 2 characters each, which equal that pair. Okay, I sort of get that. Hello, John Phoenix. It's not really a game, it's a programming challenges. But it is on a site which is, you have a leaderboard and it's competitive as well, so it can be thought of as a game. Yeah, so we want to find that pair twice. And the next condition, it contains at least one letter which repeats with exactly one letter between them. Okay, that's easier. Wish I knew stuff because my PC is trashed and I have no clue what happened. Oh, really? Sorry to hear that. You know, I was, I don't know if you know, but I was running 100% the other day and the day before. I didn't have any barong luck though. I just spent hours farming Braum to no avail. I mean, I was mainly doing it because I wanted to test out my tracker, see how it looks on stream. But it's, I mean, it's tough because when you put the tracker along with your stream and your chat window and stuff, it is quite hard to read, but it's all right. All right, so this condition is okay. All right. The first conditions are not really a one-liner. Well, I can't really think of a way to do it in one line, but it's still all right. Okay, so we've got two conditions to check this time. So rec 1. So we're saying we want a pair, and we want that pair to be somewhere else in string. So for I range -2 hang on, let me have a think about this. Okay, so first of all, that should be -1. Pair equals, so the pair we're comparing, so that the base pair we're looking at is S from I to up until I plus 2. That's a slice of 2 characters. And now we want to check the remainder of the string without overlapping with that pair and check if that pair exists anywhere else. So for j in range, so starting from I plus 2 and ending before length of s -1. Pair 2 equals the equivalent if pair is the same as pair 2. So we're keeping track of a rec here. So rec 1 equals false, and the moment we find it to be true, rec 1 equals true. I suppose we can break out of this loop, but it's not going to break out of the other loop. It doesn't matter. It's not harming us going through the whole string. All right, so that does rec 1. I might have to double check that, but rec 2 is easier. 2 equals any S0 is the same as S2. Oops. I is the same as I plus 2 for I in range length S minus 2. So that's checking. It's going through all triplets essentially and checking that the first one is equal to the third one, whether the first one is equal to the third one. If it finds any, yeah, that seems right. All right, I'm less confident with this one, but let's see. $55. Correct. Yeah, so I don't know if some really clever one-liner for that first condition, but you don't need one. It would actually obfuscate things if you did. It's probably better to write it out at that point. All right, let's keep going. Day 6. Probably a fire hazard. Because your neighbors keep defeating you in the holiday house decorating contest year after year, you've decided to deploy 1 million lights in a 1000 by 1000 grid. Furthermore, because you've been especially nice this year, Santa has mailed you instructions on how to display the ideal lighting configuration. Alright. Lights in your grid are numbered from 0 to 999 in each direction. The lights at each corner are 00, and so on. The instructions include whether to turn on, turn off, or toggle various inclusive ranges given as coordinate pairs. Okay. Each coordinate pair represents opposite corners of a rectangle, inclusive. A coordinate pair like 00 through 22 therefore refers to 9 lights in a 3x3 square. The lights all start turned off. So if you follow these instructions, you're turning off. So I can see this as being one of those problems where there's like clever algorithms for doing this more efficiently. But we might not need them because you don't normally need to know any algorithms for these problems. Just common sense, well, good programming sense. But you don't need to know, textbook methods, which are kind of advanced. Because I've seen data structures used for this, like, I can't remember what they are, like KD trees or something like that. So let's just do it the brute force way. So, ooh, it's in kind of natural language. Okay, fine. We can deal with that. All right. So we extract a line. We need to parse all this stuff. So we want to get all right, I guess the easiest way to do this is to just say tokens equals line dot split dot strip first, take off the new line characters, then split it by spaces. So we'll end up with like turn off, and that would be one chunk token, then that, and then that would be one token. The only tricky bit is that we either have one token in front or two tokens in front before the coordinates that we want. But we can say if tokens 0 is toggle, then x1, y1 equals hang on, just say I index equals, just do this as a one-liner. Ix equals, so if it's toggle, we want 1. If that, else 2 would be the next one along. So x1, y1 equals int, we want to convert the numbers to ints for z in tokens. So that gets us the numeric one. We need to split it on the comma. Bit confusing. And then x2, y2, this one's just the same thing, but just take the final element of tokens. All right, so that gets us the coordinates. All right, so we want to just keep a huge grid of 1,000,000 coordinates. I don't think this will use too much compute time, so it'll be fine. So just use a hash table for this. Grid equals hash table. We'll say, let's use a default dict because it will default to 0 because it starts off as 0. So that means we don't have to spend time initializing the ones we don't actually ever use. So grid equals default int. So so now we just say if tokens 0 is no, let's do it like this. So if it says on, then all right, so we want to for x in range x1 up to and including x2, or y in range y1, y2, okay, so if it says on, then we say grid the at position x, y equals, let's just say true. Actually, we want a Boolean, don't we? Not a defaults to false. If tokens 1 is off, then we set it to false. Otherwise, we toggle. So we have to say not whatever it was before. And if we've never touched it before, then it's going to be false by default. And then finally, how many lights are lit? Either we count them up as we're toggling, whenever we're turning them on, or just afterwards we say print sum of grid.values, because the values are just trues and falses, and it'll add 1 for every true. Might take a while. This is millions of lights. Well, it's 1 million lights, but you're toggling up several of them on and off a lot. All right, not too long. Correct. You just finish implementing your winning light pattern when you realize you mistranslated Santa's message from ancient Nordic Elvish. The light grid U-board actually has individual brightness controls. Each light can have a brightness of 0 or more. The lights all start at 0. The phrase turn on actually means that you should increase the brightness of those lights by 1. Turn off means you should decrease by 1. The phrase toggle means you should actually increase the brightness of those lights by 2. Alright, so this is going to take the same time to run, because we go through all the same lights. I'm just changing a bool to an integer. So it should be correct. Let's copy this all again. So instead of bool, we want this to be an int this time and default to 0. Read all the input again, I guess. So we parse it the same, do all the same stuff, but we say if it's on, then we increment it by 1. If it's off, we boo. So we need to not go below 0 though. So we say equals max of 0 and that minus 1. Otherwise, we increment it by 2. And then we do the same thing. So now we print the brightness values, the sum of the brightness values. So it's doing both of those one by one. So start with the first part. So it should take the same amount of time. It's just doing the same thing, but with ints instead of bools, which is roughly the same compute time. Does that look about right? Probably. Woo! Alright, day 6 done. Should I keep going? Yeah, probably another half an hour I can keep going. Ooh, this looks like one for Python. Alright. This year, Santa brought little Bobby tables. Ah, good old Bobby tables. If you guys don't know the Bobby Tables reference, it's a very old XKCD comic. That's the comic there. It's kind of an SQL joke. The idea being that the mum named her son a set of SQL code which would cause the school's database to basically delete the whole database of students if they ever entered their son's name in that format. This bit here, drop table, deletes the students table. And that is, of course, a real security thing. That's a real security hazard. Like, people do this. This is SQL injection. You can do this to hack into websites. I'm pretty sure during the pandemic, this actually happened in the Thailand's database for all the people getting vaccines. They made a website for you to sign up for vaccines. But of course, because it's the government, they hired rubbish programmers to make the website. And someone just did some basic SQL injection and managed to retrieve the entire database of people who had signed up and their address details and their phone numbers and everything. Which is a massive security flaw and a privacy nightmare. But yeah, that's what happens when you don't sanitize your inputs. And this is from which year? When was this published? This particular comic. At least 15 years old, I think. More, actually. I think over 15 years ago. Alright, well, that's the story of Bobby Tables. This year, Santa brought little Bobby Tables a set of wires and bitwise logic gates. Unfortunately, little Bobby is a little under the recommended age range. Well, he must be... Oh, well, okay, this was 2015, so it was 8 years ago. He must have been about 9 or 10 years old if we're using the comic as his... I don't know. I don't think Bobby ever ages. Alright, each wire has an identifier and can carry a 16-bit signal, i.e. a number from 0 to 65535. A signal is provided to each wire by a gate, another wire, or some specific value. Okay. Each wire can only get a signal from one source that can provide its signal to multiple destinations. Okay, so it's like a circuit when you're programming a Boolean circuit. One's getting weird. Yeah, well, it's quite field specific. I mean, it's not. It's to an electronics engineer or electrical engineer, I think is the term. This looks pretty ordinary. Okay, so I think a diagram would really help here, though, but they don't normally have diagrams, so just have examples. The included instructions booklet describes how to connect the parts together. X and Y means you put X and Y into an AND gate, and the output goes to Z. Okay. Yeah. So yeah, an AND gate is like a... Let's open up this. Well, this is not helpful. It's a physical device where you put in two signals, and the signal that comes out is 1 if both signals going in were 1. So it's AND. It's the AND logic. When I say 1, I really mean like 5 volts or something. So, all right. So let's have a look at the examples. 1, 2, 3 to X means that the signal 1, 2, 3 is provided to wire X. So the signal can have values from 0 to 65535. Okay. X and Y Z means you take X and you Y and you AND them together. So if you AND, well, they could have given us a numeric example here. If you ANDed 1, 2, 3 with 3, 4, 5, you would have to turn them back into their zeros and ones. There's Python methods to do that easily. Do the AND bitwise for each pair, and then turn it back into an integer. Actually, no, you literally just use the AND operator in Python. It does that all for you. So we've got L shift. The value from YP is left shifted by 2. So that means you basically multiplying by 4 because you're shifting the, hang on, which way is which? So logically, so shielding shift left means you're multiplying by 2. So from 0001 you go to 0010 and so on. Shift right means you're dividing by 2 and you're discarding you're rounding down. Okay. But we're doing an L shift of 2. That means we do that twice. So you're actually dividing by 4 or multiplying by 4. And then we've got not. So you take the bitwise complement. Okay. If for some reason you'd like to emulate the circuit instead, almost all programming languages provide operators for these gates. Yeah, that's what I was planning to do. So we follow the wirings, and then what? We want to know what signal is on A. Okay, this is interesting. Alright, it's not fundamentally difficult, it's just this is like electronics 101, but it just needs careful attention to each detail. So where's our input? Okay, that's all right. It's quite pausable. No XOR, no. So they said these are other possible gates, but I think they mean. Wait, I don't think those will appear in this input. Oh, they do. They got right shift. Okay, so yeah, there might be XOR. We can check. No. Wait, did they mention XOR? Probably not. No, just OR and R shift. Okay. So we need to do those as well. Okay. So we want to keep basically a table of values for each wire. So let's say table equals just an empty table. So go through line by line and we have to parse it. So we say interesting. Okay. Are there lines which just assign raw values? What would it look like? So where does it all start? There has to be some raw values being assigned somewhere. Wouldn't there need to be? Let me have a look at this again. Yeah, so like 1, 2, 3 to X means 1, 2, 3 is provided to X. Do we get lines like that here? Yeah, here we go. So these are like the starting points of the circuit. Ah, so it's not in order. It's not in topological order. So you can't compute this right now because you don't know what LF and LQ are. It's to be done in topological order. That's tricky. Well, trickier. So there's a couple of ways of doing this. So there's a thing called topological sort, which is where you basically sort these in an order which is guaranteed that you can just do them one by one. But we can also use a graph data structure where we build a graph edge by edge. Then we end up with a graph. And then to find A, we just find A in the graph and recursively compute all its parents in order to compute A. And the good thing about that is that you actually don't bother with all the lines which are relevant, because some of them lead to circuits which never reach A. I have to have a think about this. How do I want to proceed here? Okay. I mean, the important thing is that if we take any of these strings, DE, for example, there will only ever be one line in this whole list which will have DE on the right-hand side. You're not allowed to have two things that map to DE. It's the way the circuit works. So each time I encounter one of these lines, I can put in my table key, using fm as the key, for example, the value will be this expression here. I fill my table with all those expressions. And then when it comes to finding A, I look for A. Where's A? Well, we want A, nothing. I can't remember where it is, but there's a line somewhere which says something points to A. We look at A, we look at its expression, and then we recursively compute the values in each of its expressions, and then recall the algorithm on those, and so on, backtracking through all the recursive expressions until we find the values of those branching expression of values, and use that to compute A. It's recursive, basically. And it'll work because there's a unique expression for each field. It's difficult to explain. I just need to start coding it. But it won't take long to code because that's the beauty of recursion. You just write it recursively and it just works. So what we want to start off by doing is just split this into two parts. We want to split it by this string here. So L will be the left-hand expression. R will be just the string here. So we say table R equals L. And that's all we do for extracting the input. So then we'll end up with a table which looks like this. Okay, so we've got, for every string, we know what its value is. It's just that its value is not a closed expression. All right. Now, we have to define our recursive method. So define get val. So this method, given a string, I want to find the numeric value in the table. So I don't want to return the raw string. I want to numerically work out what it is. So I need to handle all the cases. So the easiest case and the base case is if it's just a number. So if s.is digit, nice Python method, is if the string is all digits, then return just the integer value. Okay, there's another thing I need to do here. I need to memwise So whenever I find a value, I need to put it into a storage so that I never have to compute that value again, because otherwise I might end up computing the same thing over and over again, and that would use a lot of time. So if s in mem, that means we worked it out before, return mem s. If s dot is digit, mem s equals s digit is, whoops, that. All right, that handles the easiest case. Now we need to handle all the binary expressions, because there's two parts to them. No, well, there's unary expressions as well. The knots. Let's deal with the knots first. Okay. If s dot starts with not, then s1 equals s. So we want to. So we go 1, 2, 3, 4. From 4 onwards, take that to be our substring. We now call getVal recursively. So that's now a numeric value. It's just going to call this again to get that value. So S1 is now a number, and we want the bitwise complement of the value, but in the range 65535. How do I do this? Let's look this up. Python bitwise complement. Okay, you use the tilde operator, but I don't think that's enough. Because it needs to know the max range. I'm just having a look at the different methods. So we don't, it's not 32-bit. Can't find a proper link explaining how to do this. Oh. So it was, how much? It's 6 16-bit. We want 16-bit 2's complement is what we want, not 32 bits. I think Python 16-bit 2's complement. Okay, if you want to get an inversion of only of the 16 bits of a number, you can take the XOR of that number with 65535. Yeah. And add 1 to the result. Oh, so I don't need to use the... All right, let's try this. Okay, so they're saying, okay, so will this run? Yeah, okay. So we want to do, let's say we want to invert the number 3. So x equals 3. So we want to do, so you want to XOR with 65535 and add 1. Is that it? No, that's not it. Hang on. Oops, I was supposed to... Yeah. That 65533. Is that right? Hang on, so 3 is 1 1. 65535 is like 1 1 1 1 1 1. So what we're doing is we're turning the ones into zeros and those into ones. So we would end up with zeros at the end. So it'd be basically it would be 65535 take away 3. No. What? Is this right? Is that... No, I can test this properly by doing this. So we do print bind x, do it in binary. We want to say z equals x with 65535. It's getting quite complicated. I didn't think not would be the hardest one. Maybe it is. Yeah, no, that doesn't look right. I don't know what this tutorial is telling me. Alright, let's find another one. Alright, I can't find any tutorial for this, so I'll just have to write the whole method from scratch, because... Alright, maybe this is the correct formula. Yeah, I don't know what XOR's got to do with anything. I don't think that was right. Alright. No, but it shouldn't be... What? Alright, just write this completely from scratch. I'm wasting time here. Alright, so it probably won't be that hard either. Okay, so you want a string of 16 zeros or ones. So let's say t equals bind of S1. That will get the binary from 2 onwards, because that gets rid of the B at the 0B at the front. Dot how do I do this again? I want to pad it with zeros. Dot Z fill. Dot Z fill. So that will fill it with zeros at the front until it has 16 bits. Is that right? Let's test this out. So X equals 3. Z equals print Z. Yes, that's correct. Now we want to turn each 0, 1 inside out. So I'm sure there's an operation which does this for you. It's a bit stupid that I'm having to do this. All right. So 1. All right, bit awkward. And then result equals, so we need to put 0b back in front. And then what? In 16. Does that work? Alright, this problem is getting a bit messy, isn't it? I think the ands and the ors will be easy. It's just the not, which is weird. What the heck? That is so wrong. Ah, no. It's just this bit that's wrong. So... that's correct. How do I convert that back to... how do you convert a binary string back to an int? Use bin to turn it to the string. I don't remember. Oh, not 16, that's hexadecimal, it's 2, because it's binary, whoops. There we go, 65532. Wait, wasn't that what I had? Wait, 65532. Well, maybe it was right. What I did before. Anyway, I spelled it out exactly, so we'll stick with this. All right, so that's correct. So yeah, that's not. That whole thing is not. All right. Get rid of this. Yeah, it was int, but I needed to change that to a 2, not a 16. 16 is hexadecimal. I was getting confused with binary. Okay, so that's a mess. So if it starts with not, we take the number, turn it to binary, take off the first 2 characters because those are just like the identifier for binary. Put some zeros in front until we have 16 digits altogether. Oops. Then we turn all the ones to zeros and vice versa. Then we put 0b back in front. And then convert it back to an int. That, okay, fine. Let's say mem s equals result. Turn m s. Okay, we're getting there. Now we just do the easier ones. So it's just, let's go with ors and ands. If or in S S1 S2 equals split on or. Yeah, so I'll get us these two strings. And then we simply do mems equals get val of the first, and then or is where is it? Where's my... I forget how to do a vertical line. It's not on my keyboard. Oh, no, it's there. There it is. Or... I think that's the correct symbol. Let me just double check this. Python bitwise or. Yeah, and is just ampersand. Okay, so those bitwise operations handle it correctly. I don't need to do any trickery here. All right, and then if we've got L shift, S1 equals, okay, so we've got S1, and let's say D for the number of digits, equals S dot split L shift. So that gets the two values we need. So we need to do M equals get value of S1, and then we need to left shift, and that operator is so the number corresponds to the number of shifts to do, right? Let me have a look at this again. Yes. Okay. Oops. Return mem s. Hello, Rome Freak. Not quite learning Python. I'm just basically using it to well, yeah, I am sort of relearning how to do bitwise operations because I don't often do them. But I'm using Python to do the Advent of Code 2015. And this will probably be my last puzzle because I'm about to finish, but I don't know if I'm close to finishing this one because there was a part 2 for this problem as well. So repeat this, but with a right shift. It's a game, it's kind of like I'll show the screen in a minute. It's a website with puzzles, and it's competitive as well, but this I'm doing an archived competition, so it's not live anymore. But I'm still trying to complete it. So this one is R shift. So we do that. So I believe that's all the operations we might get. No XORs. Yeah. So it calls these recursively. So all we do is print get val of A. Is it small case A? Yeah. And it should just call all of these repeatedly on all the branches until it finds what A is. I don't know if this is going to work. None. Alright, let's have a look at this. Oh. Oh, wait. No. I've not used table. I didn't use table. Given a string. So if S is in memory, we return the value. Yes, okay. Let's say var. Don't use S, use var. If var is in memory, we return what we found. Okay. Otherwise, S equals table. This is the expression that defines var. Now we do all this with the table value, not var itself. Var is just like A or B or C. So I'm trying to find not and or in A or B or C. Okay, now we're using the expression. All right, let's see if that works. None. Get value, so I'm looking for value A. Oh. These mem values need to use the var. None still. Okay. All right, let's make sure that A is in our table first. Print table A. LX. Oh, wait, what? Oh, that's another value we didn't account for. So if it's just a name of a wire, like LX, that's another case. So if we get to this point, the only case left is if it's just some other variable. So then we just do get value of S, because that's just some wire's name. Return mem value. Yeah, do that. All right, go. Key error 1. S is the expression. So at this S should be LX. So it's trying to do get val of LX. So what would happen when it finds LX? Print var S. All right, let's see what we're getting here. So we're making progress here. So we start by, okay, let's take this one out. It's confusing. So we've actually managed to go some levels deep successfully. Okay. So we started with A. We found that A is equal to LX. Okay. So we looked up LX. And we found that LX is equal to LW or LV. So we looked up LW, LC, L shift 1. We looked up LC, LB or LA. We got LB, AH. Still going down the tree. KG, JM, LJL. Okay, so where did we crash? Okay, so we got to UT. U is equal to T or S. T is equal to C shift 1. C is equal to 0. So if C is equal to 0, then that means T is equal to 0, L shift 1. So still 0, I guess. So U is equal to T or S, 0 or S. S is equal to 1 and R. And this is where it crashed. Key error 1. It didn't like the number 1. Oh! If we plug a number into this, which is literally just a number, like 1, we should just spit out the number 1 instead of trying to parse it. If var.isDigit return int var. I think I'm trying to put 1, the string 1 into this. And I didn't count the case where it's literally just 1. Or just some integer. Let's try that. There we go. Well, we got an answer. I do not feel confident with this though. 16076. Okay, that was a bit of a ramp up in difficulty from the last 6, wasn't it? Oh, it's correct. I mean, yeah, once you actually get it to work, it's probably going to be correct because it's sort of, well, apart from that not condition, which was a bit sketchy. It's the error that you're most likely to get is probably a recursion error or a stack overflow or something. Not an arithmetic error because that stuff was kind of reliable. All right, part 2. Now, take the signal you got on wire A, override wire B to that signal, and reset the other wires, including wire A. Huh? We can do this manually. Okay. So we got 16076. We want to find B and set B equal to that instead of whatever it was. That's the only change we make. Everything else is just left as is. And then we want to find A again. Okay. So, to do this, that's not too difficult. We just say table. Oh, let me switch back to the... So I want to put in a hack. I want to say table. I want to find B. And whatever it was before, just change it to be this. So B is now equal to that. Mem, just clear all the memory so that we don't try to use old and incorrect values. And now just do this again. Also, let's stop printing stuff. Alright, I mean, this should just work then. I mean, if it worked before, it should still work. It's the same method. We literally just setting B to be this number. 2797? If my thinking is correct here, it should just be fine then. Phew. Yeah, I mean, yeah. That part 2 was nice and easy because there's no real trick to it. You just redefine B. Cool. Okay, so it wasn't fundamentally difficult, that problem. I tripped up on the two's complement. Two's complement is a weird one because it's like you never really use it as a programmer. Unless you're doing some really low-level C programming, but it doesn't look like there's a nice way to do it in Python, at least for specific size, a specific number of bits. I think the Python complement built in, it depends on the number of zeros in front of your integer, but because you're providing it as an integer, if you give it 3, it interprets it as 1 1, not 0 0 0 0 0 0 0 1 1, and that's different because the 2's complement of 1 1 is, well, it depends on the number of bits you use, but if you're doing it with respect to 65535, it would be 1 1 1 1 1 1 1 1 1 0 0. If you're doing it with respect to 255, it would be 11100, but with the right number of bits. So it matters what your upper limit is. It'll give you get different results. But the same can't be said for and or, because if you take two numbers and you add them together, that's defined. You don't need to say, oh, this is 16-bit or 8-bit or something. There is one and only one and there's one and only one or, but not, when you do not, that's a tricky one because you have to know what the upper limit is. All right, well, I think I'll stop there. I got further than I was expecting. So that's 1 week, 1 week's worth of problem. But clearly they're getting harder, so it might take me like an hour per problem, maybe longer. I mean, you can get problems which take several hours, and it's good. Yeah, so this is the site. Skip to 25. Oh, no. That's hacks. That's a task run. If anyone at home wants to do this along with me, you can actually join my leaderboard. So like if you make an account on this website, it uses GitHub or Google and stuff like that. And this code here, you enter that code, you would then appear here on my leaderboard. It's just a fun thing. It just shows which problems you've solved. These are 2 viewers I had before. So Patagonia has already done this calendar fully, apparently. Yeah, it's pretty cool. 2022. There was some really scary problems towards the end. I don't know anything about coding other than doing the Hello World code in high school. Well, I mean, this site is accessible even to beginners, but only in the first few problems. So I mean, I just did them now, and I think it's still a bit mathsy. So it's not, if you've only done Hello World, maybe it'd still be hard. But I mean, to someone who's done basic scripts, like at the most basic level, I would say the first couple of problems are still accessible, but you will reach a point where you can't really continue. But I mean, the problem 1 that I did earlier in the stream was you start at floor 0, and every time you see a left bracket, you add 1. And every time you see a right bracket, you subtract 1. So you just go through all of them, and then you just have to say what the final number is. So that's kind of one of the most basic kind of problems you can have, which involve, some sort of decision process. Might try the 2023 one. Well, yeah, that'll be this December. So yeah, December the 1st. But there's no rush. Lots of people do it like not the day that they don't do it the day that the problem comes out. Many do, but many people just take their time over it. They're still probably solving 2023's problem, 2022's problems to this day right now. But yeah, it's quite fun, and there's so many resources and forums and stuff, so if you get stuck, everyone who's on this site is kind of doing the problems, so it's a good way to lots of people stream it as well. It's becoming very popular to stream. Some people speedrun it. They literally put up a live split timer, and the moment it comes out, they try to beat it as fast as possible, and I can't really do it at that level. Those guys are insanely fast. Like, they'll solve it in seconds. This problem here, they would solve literally in like 3 seconds. They'll just be like, type.count. Like a small one-liner, a few characters, and then that's it. And when I say in seconds, I mean that includes reading time. That's the trickiest bit. Because they're so used to these problems. They can just look at that and they can spot the keywords and immediately see what in general they need to do, and then start coding immediately. Alright, Rome Freak, yeah. I mean, I'll try and do this like every couple of days or so. I mean, maybe every day. It depends how much I'm enjoying it. I might carry on tomorrow or the day after, around the same time, I guess. This is more of a daytime activity. In the evening, I end up playing video games. Yeah, it's an educational stream. You can learn from it. I get lots of viewers for these coding streams who don't code or don't even know the first thing about coding. They just find it almost therapeutic to watch me solving coding problems when they have no idea what I'm talking about. And like, if you ever work in, I mean, as I mentioned to Umaro, game development uses mathematical AI sometimes, especially if you're working with like, I don't know, Unity and you're doing some geometry, physics-based calculations and stuff. Or, I mean, some of these problems were game-like, I would say. Oops. Well, there was one involving volumes of cuboids. That's something that comes up, like game development, or MD5 hashes. Not so much. Well, like this was sort of like pathfinding. You've got symbols which are telling you whether to move north, south, east, or west, and you find out where you move. Pathfinding is like the single most important AI technique. I mean, practically all of AI is just pathfinding. Finding a path from A to B, but doing it fast, because it can be a heavy calculation if you have lots of enemies and they're all trying to find paths to you or away from you or behind cover so they can shoot you. Yeah, AI is kind of my specialty, so I do sometimes do AI streams for an AI competition, which will be coming up at some point. And in those, I go into a bit more detail about like pathfinding, A-star algorithm, finite state machines. It's a bit more technical than this, but Umaro, do you use any AI for your game? Like any pathfinding? I suppose if it's like Azure Dreams, you would have like basic grid movement, right? And if you do you like, does the game engine you use just have something built in, or do you override it with your own? Like, I suppose for Azure Dreams, the most standard one, just do like breadth first search or A-star search, if there's not going to be many obstacles in the way. If there are going to be obstacles and windy corridors, then you can get a payoff by using like A-star, which is one of the gold standard pathfinding algorithms. But yeah, the pathfinding code in Azure Dreams, like what's actually in the PlayStation code, is actually one of the most complex sections in the whole game's code. Programmer had a look at it, and he hasn't even fully interpreted it all, because there's some sections of code which he knows is computing the pathfinding, but it's actually too complex to interpret from the from what we have available when we check the bytecode. So Azure Dreams pathfinding is pretty complex, because in those days they couldn't really do what we can do today. They couldn't write like some A-star algorithms. They had to do some really hacky stuff, which accounts for low memory devices. I'd like to make a game with a neural network one day. Yeah, that'd be cool. You could just have your game make calls to ChatGPT. I bet that would be the future of games. You're playing Fallout and you have a conversation with someone, and it's literally making calls to ChatGPT to answer you. So it's like, So it's like you're talking with a real person. They're bringing up all sorts of like topical discussions, and that'd be crazy. But that's possible. The only problem is it means it's a live game that has to make live calls to the server. So I don't like single player games which are online only, but if someone wanted to do that, they could. I mean, ChatGPT offer like business packages for exactly that kind of purpose, so that's a very viable thing. It's just I don't know if anyone's tried to do it in a video game before, but you could be the first. You could have real flirting with the girls just in as dreams, but just it's like real. Do you have any like Discord or website or anything where you're kind of updating people on the game, or is it still just like in the early stages, so you're not really public about what you're doing? I do have one, but it's not very active. I mean, you could drop it in the As a Dreams Discord if you haven't already. I think several people there would be happy to just drop in and be notified with updates and stuff. I mean, Sand Knight said he's interested, so. Okay. I think it's time for me to go cook some food. I got some shrimp. Fresh shrimp. No, it's not fresh, it's frozen, but good enough. Yeah, so that was the first 7 problems. That's more than I expected I'd get done in one stream. It will only get harder from here, though. Well, there may be some easy problems coming up, but in general, the difficulty will ramp up. So, cooking speedrun. Oh, yeah, that's definitely a thing. There's like the tacos speedrun, which is actually quite big. I mean, there's rules about what utensils you're allowed to use and which fillings you need for it to count as a taco. Oh, yeah, that's a thing. If I had a GoPro or something, I would do that. My webcam here is not really suitable for that. I mean, I might come back with some As a Dream speedruns later. We'll see. If I finish my dinner with enough time to spare, maybe. But I think probably no. I think I'd take a break from As Dreams today. We play something else. Let's see. All right. Thanks for watching. And you too, Run Freak. Maybe I'll see you in the next few days, and together we will conquer 2015. And then 2016, 17, 18, 19, 21. And then I will be prepared to take on 2023 this December. I think there's no way I'll get through all those in 1 year. I think I'll just have to become a full-time Advent of Code streamer. Maybe I could. All right. See you later. Bye-bye.